How's it going, guys? Welcome to another video here. What we're doing right now is basically under the section of ratio, proportion, and percents using the percent formula. Okay, I'm going to read these key ideas. Not going to go over this whole thing here. Let me see something real quick. I want to make my mouse more visible to you guys. Let's see if I can make this happen. I should have done this before I started the video, but I didn't. Okay, there you go. You can see it a bit more, this blue dot. Okay, let me see if there's another dot. Anyways, probably not. Okay, so, yeah, I'm going to go over these key ideas. You can use a formula to solve percent problems. Base times rate equals part. To change a percent to a decimal, drop the percent sign and move the decimal point 2 places to the left. Okay, so that's what they're doing here when you're doing base times rate. That formula, they're actually, it shows you, it tells you that it's 70%. The rate, for example, company offers its employees 2 health plans. In a recent newsletter, personnel department stated that 70% of the employees chose plan A. If the company has if the company has 320 workers, how many chose plan A? Hold up, let me make this a little bit bigger if I can. Oh, come on. Let me get rid of this dot here. There we go. So it's showing us 70%. Okay, so when we have the base and the rate, okay, which is the rate is always the percent, okay, and the base is the total amount. In this case, if the company has 300 employers, the base would be 320. Okay, so that would be the base. It's never changing. There'll always be 320. Then we find the other variables. 70% is a changing variable to 320, as in, it's not the total amount. Also, the part, which you can see up here, would also be a variable that changes as well. Say 300 people go to work that day, and tomorrow only 310 go to work. But there's still 320 workers, so that base is, you can expect it to be pretty ongoing. Okay, so let's see. So in this case, when you actually do base times rate here, like it shows in the formula, this is the base amount plus the percent. You would drop, as you can see here, it's 70%, but they move the decimal over because you want it to be a regular number. You have to multiply like numbers, so a percentage isn't necessarily a number, it's a fraction of a number, whereas we know it's less than 1. So imagine that the percent, what do you call it, that the decimal is right after the 0 here on the 70, and you would move it twice, like it said 1, 2, which is what they did, and they put 0.7, to let you know it's basically not a full whole amount yet. Okay, so to change a percent to a decimal, drop the percent sign and move the decimal point 2 places to the left. Okay, we did that, or I explained that. To change a decimal to a percent, move the decimal 2 places to the right. Okay, so you would do that in the let me turn this off again so I can slide this up. Okay, so you would do that when you're doing part divided by the base. Okay, so I don't know if you watched the last video, it kind of, we go through parts and bases and stuff when we actually do the problems, and rates as well. So for example, the base is 1600. Okay, wait, a computer system is regularly priced at $1,600. On Friday, the manager reduced the price by $640. So here we have the base, which is, we know that the regular price is $1,600. It's been reduced by $640. It could have been reduced by $600 or something else, okay? So we put the part up here and the base down here. Basically, you're dividing the part by the base. As you can see here, 640 divided by 1,600. And we're trying to get a percent out of this. So this again isn't a percent, 0.4. It's a regular number, whereas a percent shows a little bit more that it's a fraction of that number, especially in percent form. Okay, so in this case here, when you actually, they get this problem here, 0.4 means that it's 40%. Okay, so you would just move it over if you were going to put in percent form. 2 decimals like you see here, the 4, move it over once, move it over again, now you have 40. That's 40%. Okay, so that's pretty much that. Everything you need to know on the first page. So here, this is where the problems are. Okay, so let's go ahead and start. Okay, so we're going to start with one. It says solve. You may use a calculator. Okay, what is 20% of 25? Okay, so we're going to try and write it like the formula there. What is 20% of 25? Okay, so we have the rate here, which is always the percent, and we have the base here, which is 25. So I'm going to go ahead, set up the formula. Okay, so instead of putting the P here for the part, just imagine that this is shaded out. Anything we're not going to be working in is considered shaded out. Okay, so we have B, which is the base, times the rate. We're solving right now for the part. Okay, so we have the base and the rate, so we need to multiply the base times rate. Okay, so that is 25 is the base times the rate, which is 20%, but we need to change 20 to a regular number because we can't type multiply regular number by a fraction of a number. Okay, so that fraction of a number would be considered this right here. Move it over to move decimal over 2 places. So at 20%, decimal was here. Moved it over here and over here. Okay. So we go 25. Let's do this. 0.2. You don't actually have to include the 0 because any 0 after, if it's the last 0 without any other numbers after it, or say 3 zeros in a row but no actual numbers 1 or greater after it, then you could just drop the 0 because it doesn't actually have any value. So 0.2 times 25 equals 5. Okay, so we know that what is 20% of 25? So 20, basically 5 is 25%, And let's see, we could actually verify that, I believe, by going 20 times 5. It should equal 100. Okay, there we go. Because at the end of the day, a percentage is a part of 100. Okay, and this represents 100. Okay, the base represents the total amount. So don't think of it as 100, but the total amount that that this is a percentage of, that 20 is a percentage of. Okay, so 5 is the answer there. Okay, now we are going to do number 2. Find 90% of 200. Okay, so again, we have the base and the rate. Okay, so this is shaded out up here. Base times, I am using a mouse pad here, so bear with me because you can't write as good with a mouse pad. Okay, so base times rate, which is 200, times the rate, which is 90, but remember we can't do, it's 90%, but we can't do fraction of a number. It needs to be understood as an actual number. I'm saying actual number. I'm sure there's probably a better way to say it, but I hope you get the point. So now think of it as 0.90. So we need to multiply that. Remember, we don't need to include the 0 here because it's at the end of this number. So 0.9 times 200 equals 180. Okay, so that's your number here. 90% of 200 equals 180. Okay, let's go ahead and clear this. Okay, what is 35% of 400? Again, base times rate. Base times rate. Okay. Let's see, the rate of the base is 400. The rate is 35%, but remember, whoops, remember, move the decimal point here. Now it's 0.35. Okay, so let's clear this. 0.35 times 400 is 140. I know this may be confusing in the sense that you're like, oh, if you're not too familiar in thinking of multiplying decimal points or percents or fractions, you may be thinking, well, how does 35 times 400 equal 140? Should equal, let's see, I'm just going to write that here so we remember. 140, it should equal, let's see, 35 times 400. You're thinking it should equal probably, is it 14,000? Yeah, 14,000. So, well, the reason is you're actually multiplying 0.35 is less than 1. In fact, you can almost fit 3 0.35s in just a regular number 1. Okay, so you're actually making this number smaller by doing that. Okay, because anything times 1 is itself, like 1 times 400 equals 400. Now imagine multiplying less than 1. Say 2 times 400 as well as 800, so then it doubles. But when you're doing the number smaller than 1, it gets smaller. Okay, so that's the concept behind there. Anyways, for that number 3, it's 400. Okay. Now, number 4, what percent is 19 out of 20? Okay, they changed it up a little bit. So, let's see. This one here is, this is where the rate would go here. We'll shade it out. Okay. Base goes here. So this time we have the part, guys, divided. So part divided by the base. Okay. So the part is, what percent is 19 out of 20? So we have 19 here, which is the part, and it is divided by the base. So when you divide a smaller number by a larger number, you're going to get a decimal number. So 19 divided by 20. Let's go ahead and do this. You could do it on paper. I'm using the calculator because this isn't a division class or a multiplication class. We've covered those already, so you should know them. If you don't know multiplication and division by now, please go back and learn that first, because those are foundational. Okay, so 19 divided by 20 equals 0.95. Okay, so equals 0.95. But okay, basically we have the, in this case, instead of having the rate, which is a percent, we have the part and the base. Okay, but we're trying to find the percent from these two. So remember, this can't be a percent. This is more like a number, regular number form. To make it a percent, we just move it over like the first page showed us. When we have the rate, we move it to the left 2 times before we get the answer. Here we move it to the right 2 times when we have the part, after we have the answer. So that equals 95%. Okay, are you with me? If you don't, we're going to do quite a few of these. As you can see, there's 16 of them. So if you didn't just get that by the end of this, hopefully you will. So again, we have number 5, not again, but we have number 5 here, which again is 42 is what percent of 68. So again, that's a part and a base. Okay, since there's no percent sign there, okay, we know we have the part. And again, the base is the total amount. What 42 is what percent of 68. So think of this. You have 168 people and only 42 want to go swimming. Okay, so what percent of people want to go swimming? So we have the base. The base is 168. Okay, then we have part, which is 42. We have 42 swimmers. Hooray! So, oh, sorry, I should have put part right here. Okay. In fact, I will. I'll just go part. Okay, so the part, which is 42, divided by 168 is 42 divided by 168 equals 0.25. Okay, so we have 0.25. Remember, when you have the part and the base, you move this over because we're trying to find the rate, which is in a percent form, and the percent form can't have the decimal. So now we made that 25. Okay. Okay. The reason that kind of works is because these still they still mean the same thing. We know that a percentage is a part of a number, okay? And so is a decimal in this case. A decimal number is a part of the 168 here. So, you know, 0.25 in decimal form is always 1/4, which you can think of as 1/4. You have one out of a 4-piece pie, you have 1 pie. Okay, that means you only have a quarter of the pie. We also know a quarter of a dollar is 25 cents, okay, which is right here. And that 25 cents is 25% of a dollar, of the dollar that you have. Okay, let's see. Does get a little trickier on some of them, so stick with me here. So what percent is 18 out of 600? Same thing. Let me just do P instead of doing the whole formula for you. P divided by B, part divided by the base. The part is, we have 18 out of 600. Okay, the part is 18. The base, which is the total amount, is 600. So 18 divided by 600. Where's our trusty calculator? Oh, there it is. Okay, so 18 divided by 600 equals 0.03. Okay, so hip hip hooray. You have, I think I said 0.3, but I meant 0.03, or maybe I said it correct. So remember, in this case, we're looking for the percent, which is the rate. We can't have the decimal, okay? So we have to move this over twice. Okay. Now, for example, this case, it would look like this. You don't really need to put the decimal here. Just if there's a whole number, you know that the decimal is to the right of it. Any zero in front, so when with the decimal number, any zero to the far right has no value, and to the left of the decimal, any zero to the far left has no value. Okay, so you can just ignore this zero here. You wouldn't add that when you give your answer. So we know it's 3%, and you wouldn't have to put this decimal here. We do it just to show the work. So sorry for that terrible looking circle there. So there we have 3%. Hope you guys are kind of starting to get the picture, because if you're not, then there's no hope. No, just joking. Practice makes perfect. Okay, so here we have, okay guys, when we did our fractions, I mentioned to you guys to know your fraction, your fraction and decimal equivalents, okay, which is important. So, okay, let's just go over this. Find 33%, 33 1/3% of 51. So we know that this is the rate. So remember, when you have the base, and the rate, the formula is base times rate. Okay, I'm going to stop doing this. Sorry, that's a P for the part. I meant this. I'm going to stop doing this whole square thing here because it's long and tedious. We don't like long and tedious, do we? But remember, that's technically how you do the formula. Okay, so we have 51, which is the base. And we need to multiply that by 33. Just trying to remember here. Yeah, so remember in percents. So technically this would be like 33 point 33, because that's the decimal equivalent right there, okay, of 1/3. It would actually be 333, I believe. So, but remember, we still, when we're dealing with the percent, let's put this here so you know, when we're dealing with the percent, which is 33 1/3, we need to scooch this over twice, okay, to make it a regular number. So we're actually timesing 51 times 0.3333. That equals same exact thing. Okay, wait, 51 times 0.3333 equals 1699. Okay. And in this case, because we are dealing in, yeah, basically we need to round it off. Let's see here. 51 times 333. So we're trying to find the part here. Okay. So that equals, what we'll do is we'll round it off. Since there is a 9. Alright, there, you know, anything above 5, you round it off to make this a 7 right here. Okay, round it off to the higher number. Okay, which you should know rounding as well. So that's your number right there. Okay, let's clear this canvas. You don't always round off. Okay, some of these you don't because they're dealing with like dollars, for example, and when you're dealing with currency, which, yeah, when you're dealing in currency, you know, this would be an actual number, 16.99. Okay, but we weren't dealing in currencies. So, you know, sometimes you get change back. She says, the clerk says, she or he, let me be politically correct, 425 is your change, mister or sister, and you're like, alright, thanks so much, I'm gonna buy some candy with this. Then you go and buy some candy and live happily ever after. So yeah, that's why we rounded that off, because not dealing with currency. So what is 125% of 48? Okay, so again, we have the rate and the base. So base times rate. I'm just doing base times rate because that's technically what it is. You could really set it up to 125 times 48, but I'm just keeping with protocol here. Okay, 48 times, and I like put dollars there so I remember that I'm working in cash. 48 times 125 So, see, I'm getting ahead of myself. So, since we're talking about dollars here, we're trying to find 125%. 125% of 48. Let me separate this. It's getting confusing here. Okay. So, yeah, if you think of this, 125% of 48, when we change this to a number, that will actually think of it as a dollar, like this, because remember, this is a percent, it can't be a percent. So imagine 125% can't be a percent. We have to move it to regular numbers. So move the imaginary decimal point 2 places here. Now we have, now that it's a regular number, that 125% is, think of it as dollars, $1.25. Okay, so that would be equal to, let's see, 48 times 1.25, 60. Okay, so 125% of 48 equals 60, and we knew it was going to be a larger number because we weren't trying to find, if it was 100% of 48, it would be 48, but since it was higher than 100, we knew that this number was going to be higher, okay, than 48, which is the base. So we have, yeah, 125% of 48 is 60. Okay, so 240 is what percent of 120? Okay, it's number 9. So we have, let's see here, the part. So in this case, just like the some of the percentage or last percentage we did was larger than the base, this part is 240, so it's larger than this base. Okay, so division. Yes, we love division. So the part 240 divided by, forgot my 0, it's important because it's on the left side of decimal, 240 divided by 120, 240 divided by 120 equals 2. Okay, so remember, we have the base and the part. We're trying to find the rate. Okay, we're trying to fill in this spot here, which is the rate. So it's 2, but we need to think of this in percent. Okay, so the imaginary, the decimal, if there's no decimal, we know it's right to the right of the number. We'll move it over 2 spaces, but we need to fill those places. So 0, okay? So that equals 200%. I could put the percent sign right behind it, but just to keep it clean, I'll make a new 200. So you're asking, how could this be? Well, 240 is double 120. So if we have 120 people that want to go swimming, or 120 people in the company that want to go swimming, 120 people total in the company, and 120 of them want to go swimming, then that means 100% of them want to go swimming. Okay, if we had half of 120, which is 60, that wanted to go swimming, then 50% would want to go swimming. Okay, because half of 120 is 60, and half of 100% is 50. Okay, so 240%, which is double 120, which represents 100%, would be 200%. Okay, because since this is the base, this is kind of the standard for the 100%. Anyways, hope that makes sense. Okay, so we are on number 10 now. What percent is 3 out of 60? So 3 is the part, okay, which we know. Part, when you have the part and the base, you divide. So 3 divided by 60, which is the base, equals 3 divided by 60 equals 0.05. We can't have a percent with a decimal. We have to move it 2 times over. So now we have 0.5 with the decimal point on this side here. So remember, guys, anything 0 to the left, far left of the decimal point has no value. So there we have it. We don't really need this either because we already know, imaginarily speaking, that the decimal is here. So 3 is 5% of 60. Okay. Okay, now number 11. 52 is what percent of 650? So we have the part, which is 52, and we have the base, which is 650. Okay, remember formula: part divided by base. Okay, there's our lovely little box. Part divided by base. We're looking for the rate. So 52 divided by 650, 52 divided by 650 equals 0.8. Okay, remember the rate has to not have a decimal in it. So 0.08, move the decimal over twice. Remember the 0, not decimals here, the 0 has no value. So we just have 8%. Okay. That's number 11. Okay, we're on a roll here, guys. This is a lot of work, especially using this stupid little mouse pad here, or a trackpad, whatever you want to call it. Okay. Number 12. Find 8.5% of 46. You got it? Okay, so that is the rate. Remember, when you have a percent, that's the rate. So we have the 46, which is the base here. So B times R, base times rate, to find the part. Okay, so 46 times, so we can't have a, see how it says 8.5? We cannot have a fraction there. Okay, so like I said, know your fraction, what do you call it, decimal equivalents. You could look them up on Google or whatever. I did show them in the lesson here if you've been following, but I can't remember which one exactly it is. So yeah, so basically we know that half is 0.5, okay? So we have to go 8.5. This is number 12. Yes, it is 8.5. So now that we've changed it, this still represents, we haven't moved that decimal actually, we just put it there and changed this to, put it where it already was and change the fraction to 5. So we still have to move this over twice, remember. So 0.85 that's 0.085 times 46 equals 391. Okay, this time we do not want to round off. Let's see, this is number 12. Yeah, we do not want to round off like we did on number, what number was it? Number 7. Round it off to 17 because reason we don't want to round this off is because we're talking about currency here. Okay, 46. Talking dollar forms here, and this 91 specifically denotes that it's $3.91. Okay, so here we have it. Equals that 8.5% is $3.91. There we go. Okay, we are on number 13 now. 0.65 is what percent of $10? So again, we have the part, which is, we don't need the 0. 65 divided by the base, which is $10. Okay, again, these zeros are just placeholders without any value since they're to the right of the decimal. As you can see, $10, these zeros mean nothing. Okay, $10.00 is kind of what I meant to say. So 0.65 divided by 10 equals let's write this down, equals, well, let's do decimal point, equals 0.065. Okay, so just checking something out real quick. I want to see if, so basically, remember when we do this we have to now move this place over 2 times, this decimal over 2 times. Now we have 6 and 1/2%. Okay, because we know that 0.5 equals 0.5%. I'm just checking something here just to verify that I want to make sure I teach you guys according to how the GED wants it. So I'm just checking to make sure. Yeah, so they say here you can write 6.5% like that, or 6.5%. Okay, so either way is correct. Okay, so now let's see, number 28, find 28% of 1300. So we have the rate and the base. Base times rate. If I get it right, I feel great. Okay, so base is 1300 times 28%, which we need to move decimal 2 places over here. Okay, so now we have 0.28, so 1300, clear, 1300 times 0.28 equals 364. So that kind of makes sense. Another thing here too, guys, is look at your answer, think about it, and just try and see if it makes sense. Because, for example, if you were to, how can I explain this? Say we got an answer that was, well, we know, for example, half of 1300 is 650. So if you got a number here saying 28% was, you know, like 600, that's kind of too close to 50%. 650 would be 50%. Okay, so 600, you know, be a lot closer to 50%. Would probably be something like, I don't know, 48, maybe 47, 48, something like that. So use a little bit of logic, especially when you're dealing with these bigger numbers here. Think in terms of like parts of this. 28% of 1300, which is close to 25%. So if it's close to, you know, half of 650, then you're probably most likely on the right track. So 364 is the part. Let's do equals 364. Number 15 is what percent is 2.5 out of 4. So we have the part which is 2.5 out of the base, which is 4. So base times part divided by the base, which is 4. So 2.5 divided by 4 equals 0.625. Okay, so remember we've converted that to we're trying to find the percent, so we need to 625 right now. Need to move this decimal point 2 places over. So now we know we have 62.5% or 62.5%. It's terrible 6 there. 62.5%. Okay. So that's your answer for that one. And now we are on 16, which is 62 2/3. So find 62 2/3 of 108. So that we have the rate. Remember, when you have the rate and the base, you times them. So base times rate is base 108. Again, guys, knowing your equivalency is paramount. Okay, so 60, this is 108 times 66 point, the equivalency decimals to the fraction 2/3 is 66, or 0.66. Now, because this is a percent, okay, as you can see here, 62.2 and 2/3%, we need to move this over 2 places. Then we do 108 times 0.6666 equals 71.99. Okay, so that is your answer. Let's see, equals 71. Actually, in this case, remember, since it's not dealing with currency, we actually need to round it off. So 71.99, we need to round off to 72. Just want to check and confirm that is 100% as well. Yep, we rounded off to 72. Perfect. Okay. Now we have the story problems, which they're all pretty much exactly the same as everything we have been doing, but I'll go through them anyways. Okay, so Pat called 120 customers to offer a software upgrade. Out of those, he called 72 purchased the upgrade. What percent agreed to the purchase? So there were 120 customers, which is the base, and the part, which is 72. So remember, we need to do the part divided by the base. 72 divided by 120 equals 72 divided by 120 is 0.6. Forget the 0. 0.6. We do need to turn this into a percentage, so 2 times over. We move the decimal 2 times. Need to fill this spot here, the space. So we have 60%. Okay, another terrible 6. Another terrible circle and percent sign. So 60%. Okay. Yes, that is an option here. Okay. Now we need to go to number 18. Douglas received a 6% raise. If his old monthly salary was $2,250. Guys, before I finish, don't read this hint part. Try and figure it out just on your own before that, just to see what your apprehension of these story problems is, how good it is. So Douglas received a 6% raise. If his old monthly salary was $2,250, what is the monthly salary now? Okay, so just pause it here. Okay, I'm about to read the hint, so when you come back you can hear it. Okay, so hint: find the amount of the raise, then add the raise to the previous monthly salary. So we know we need to see what the percent of 2,250 is. So that's the rate. So base times rate, 2,250 We are dealing in currency here. Times 6%. Remember, percent we need to move over twice. Now we have 0.06, okay? If you move it over twice to the left, you do need to make sure you add a 0 because that does change the value of this number. Very important. So 2250 times 0.06 equals 135. Okay, so 6% of that 6% raise is 135. So what? Okay, so if he got a 6% raise and it's asking what is his monthly salary now, then we need to add the 135 to the 2,250. So we already have 135 here plus 2,250 equals 2,385. So that's how much he's making now with his 6% increase. So B would be your answer. B would be your answer. Has a certain ring to it. Okay. Now, at a restaurant, Levy's total bill is $46. If he wants to tip 15%, how much should he leave as a tip? So we have the rate and the base. So remember, multiplication, 46 times 15%. Need to make that to decimal, make it like a regular number. So 46 times 0.15, 46 times 0.15 equals 6.9. So since, is this dollar form? Okay, so yeah. So you can't give somebody back. Yeah, you can't. So if it was a 9 here, you know that with dollar forms there should be two numbers here signifying the cents. So right to the right you have the 9. After, next one needs to be a 0. Okay, so 6.9 would actually be $6.90. Same with 6.8. 6.8 would be $6.80. You would have to add the 0 there since we're talking about dollars. Okay, so 690 is the amount here. Okay, we are on 22 more to go, guys. Awesome. Move this over a little bit more. Okay, I'm so thrilled. Okay, so the following advertisement for sporting goods appeared in the newspaper. What percent of the original price is the sale? Little League package, Magnum bat, tote bag, and youth cleats, only $45. Originally $65. So we have the part and the whole. So remember, the part is 45 because that's the part of the original price. $45.50. 45.5. Okay. When you do the calculation, the 0 doesn't really matter. We could put 0 there since it's dollars, but it won't actually affect the calculation. Okay, so 45.50 divided by 65. 45, so you don't put the 0 in the calculation, just 0.5 divided by 65 equals 0.7. I'm going to show you guys, I am going to put the 0 in the calculation. It's going to be the same exact number. 45.50 Last time we didn't put the 0. Divided by 65 equals 0.07. Okay? But here putting it lets us know that this is 50 cents. Okay, so we have equals 0. Let me not even put 0 there. I have 0.7, and we need to turn this into a percent. So 1 place, 2 place. So we need to put this 0 there. Equals 7, 0. That is perfect. This will be percent, by the way, because we had the base and the rate, and we're trying to find percent. So 70%. D. Perfect. Okay, last one, number 21. Okay, Lydia pays $3 sales tax on a $50 purchase. Which of the following expressions could be used to find the sales tax rate in her state? So I know which one it is here. I just want to see. Well, it does say, I was going to see if it could be 2 answers, but it does say in the directions up there, find the one best answer. Okay, so to keep in the likeness of what we have been doing, so we want a complete answer here, okay? This is setting it up how we have been setting it up, because we have the part here and the base, which would be 3, okay, sorry guys, I lost my train of thought, which would be 3, well, basically what it says there, part divided by the base. But the answer that you would get from that wouldn't be the complete answer, okay? It would be 3 divided by 50 equals 0.06, okay? So that is part of the process, but that's where it would end right there, and we can't have the percent like that, okay? So we need to move this over twice, which would give us, remember, any zeros to the far left don't matter, so it would just be 6. It would be 6%, okay? We'd have to go the extra step of moving these decimals, whereas here this is taken care of on 3. So as we in our last class and the last section, when it talked about, let me see exactly what it talked about. I know what it talked about, but I want to make sure that yeah, when it was just pretty much talking about percents, ratio, let me see this real quick. See this page number here, 665, no, page number is 267. Yeah, so we were dealing these, we were solving these in like the proportion form, which if you've been following, it was in the last lesson, you'd know. But this is the way that it would be complete here, because it would be 3, which is the part. The base would be 50. Then on the percent side, this would be 100. Okay? So we're trying to find, this is the part, this is the base, this would be the rate here. Okay, which would be equivalent to this 3. 50 is equivalent to 100%. is 3, needs to be equivalent to this percentage. How we do that? 3 times 100 is 300. So we multiply towards the missing variable side, which I call the x side because you would have an x there. 3 times 100. Then you would divide back towards the side that has, well, the unused number, well, back towards the side without the missing variable. Okay, so multiply diagonally towards the side, always diagonally towards the side with the missing variable to the only number that you have. So we know we would multiply diagonally this way because we don't know the number here, so we couldn't do it diagonally this way. Okay, so 3 times 100, then divided by 50. So 3 times 100 equals 300 divided by 50 equals 6. Okay, so that formula there is complete because when you're finished doing that formula, it gives you the 6% instead of 0.06. So A is the most complete one here. As you can see, it does say up here, choose the one best answer to the question. You may use a calculator. Okay, so it doesn't say complete, but it says the one best answer. So A is the best one. Anyways, guys, thanks for watching. If you did appreciate the help here, please hit the like button, subscribe button. I'm putting videos out every week. Going to the end of the math in the GED series for 2019, which is still good. Like, you could study 2019 and 2020 and it would all be pretty much the same stuff. You would learn the same things, probably different problems. They would be different problems because they come out with a new GED book every year, change the problems up a bit, I guess, to make more money, whereas they could really probably keep one going for 5 years without, probably even longer, because it's essentially just to learn the basics, which is what the GED from any year will always teach you. But at least this way, if you do have the GED book, you can actually follow along. If you have the 2019 GED book, you can actually follow along specifically to this, what I'm showing here, because all the problems would be the same. Anyways, thanks a lot. I'll see you next time.